Hello, in this question I'm going to go over a geometric distribution question from a recent OCR A Further maths paper. In that paper, this is question 3 in the paper, so it's probably meant to be relatively straightforward, but we still need to be clear about how a distribution works. I'm going to write out give a little bit of background information here. Conditions for a geometric distribution are that it's got that each time is independent, each trial is independent, and constant probability. And we're basically waiting for something to happen. We're recording the number of times when something happens. In this case, it's about green marbles. The constant probability, we needed the replacement for it to be constant probability. In that case, for the geometric distribution. Okay, for it to be used, we need replacement so the probability is the same. And independence, well, that can be reasonably assumed from the situation described. But anyway, that's not what the question is asking, but it's worth saying that as a bit of background and as a reminder that we need to know that on this specification. Also, I'm going to write out the first few values for this distribution, but again, it's not necessary for this question. That's why I'm writing in red. So the probability of getting the value 1, that basically a green marble is picked first time, well, we're told that P is 0.3, so that's simply 0.3. But 2, we would have to get it not chosen the first time, but then chosen the second time. We must have it not green the first time, but getting a green the second time. And then when we go for third, to get the value 3, we need to have not got a green the first 2 times and then got it the third time, and so on. Now, in this question, we're being asked for the probability of getting x between 5 and 10. Right, okay, in order for that to happen, that's actually the same as the probability of x being less than or equal to 10, take away the probability of x being less than or equal to 4, because it's basically all of the ones up to 10, but taking out all of these, because 1, 2, 3, and 4 are not within the probability range we're looking for. So it's 5, 6, 7, 8, 9, 10. So it's the probability of x being less than or equal to 10 minus the probability of x being less than or equal to 4. Now, there's a useful way of working with these kind of questions. We could, if we wanted to, add up the 6 probabilities in question, which I'll probably do it that way in a second just to demonstrate how it works. But probably the quickest way of doing this is to appreciate that the probability of getting between x less than or equal to 10. So this is 1 minus the probability that x is greater than 10, because either it's greater than 10 or it's less than or equal to 10. So greater than 10, 11 or more, or 10 or less than or equal to 10, 10 or fewer. So one of those has got to be the case, and both of them can't be the set case, so they must add up to 1, hence 1 minus. Similarly, probability of x less than or equal to 4 is 1 minus probability x is greater than 4. So because either the number is less than or equal to 4, 1, 2, 3, 4, or it's greater than 4, 5, 6, 7, 8, and so on. One of those must happen, and both of them can't happen. They must add up to 1, so hence 1 minus probability x is greater than 4. The reason why I like to write the strict inequality here is because the probability of x greater than 10, there's a nice kind of property with the geometric distribution, which basically means that we can just say that is the probability of, that's the same as the probability of it not happening the first 10 times. So that's 0.7 to the power 10. Whereas this is the probability of it not happening the first 4 times. So that's 0.7 to the power 4. Which is why the final answer, and when you get used to this, you'll get used to doing it quickly. The 1 cancels at 0.7 to the power 4 minus 0.7 to the power 10, which comes to 0.212. Okay, so that's the first part, A1, done. Part A2, what we have now is the probability determine the smallest value of n for which x equals to n is less than 0.1. You can do this by trial and error, because basically what we need is the value such that probability x equals to n is less than 0.1, but is less than 0.1 as stated, but the probability of x equals to n minus 1 has got to be greater than 0.1. So we kind of need that, which you can do by trial and error, but I'm going to use logarithms to do it. Maybe a little bit over the top, because the number actually turns out to be small, turns out to be 5. So you can work out the probability that x equals to 4, which I think comes to 0.103. 0.103. And probability of x equals to 5, 0 works out to be 0.072. So probability x equals to 5 is fairly quickly obtained just by searching for that value, which is fine. But you do need justification. You would need to write both in those cases. Probability x equals 4 is basically the first one where the probability is greater than 0.1. So the first one where it's less than 0.1 is x equals 5. So that's the answer. But I'm going to actually take a logarithmic approach anyway, just to make it a little bit fancy. Although there's only 2 marks, so this would have been fine. So what you need to do is say, well, the value for n, it's got to have not occurred the first n minus 1 times and occurred the nth time 0.3, and we need that to be equal to 0. We need that to be less than 0.1, the first one that's less than 0.1. So I'm going to take logs both sides of this thing here, logs base 10, so log 0.7 n minus 1 times 0.3 is less than log 0.1. Doing a bit of rearranging of this. First of all, that's log 0.7 to the n minus 1 plus log 0.3 is less than log 0.1. And then we could take the log 0.3 over and also bring this n minus 1 to the front using the rule of logs. N minus 1 log 0.7 is less than log 0.1 minus log 0.3. Right, now we can divide by log 0.7, but bear in mind, divided by log 0.7 is effectively dividing by a negative number, so the inequality has to reverse. negative, so we reverse. So n minus 1 is greater than log 0.1 minus log 0.3 over log 0.7. Okay, so that comes to n minus 1 is greater than 3.08. So n is greater than 4.08. But it needs to be the first one. So n must be equal to 5, first integer. Probably, I say, the so long as we write the both, and for small numbers like this where you don't have to find it very quickly, it's fine to just do a kind of more trial approach, because we can see that the 0.1 is going to fall to 0.1 pretty soon in that in that, because 0.3 is the first one. 0.3 times 0.7 is 0.21, so it's falling close to 0.1 pretty quickly. So the log approach might be a little bit over the top here, to be fair, which is why there's only 2 marks. So absolutely fine to use the trial approach there, but we'd need probably, so x equals to 5. So this is, I'd probably write, just going back, this is less than 0.1, this is greater than 0.1, so that implies x equals to 5 or n equals 5. Okay, so that's the second part. Then there's another part to do with a geometric, which involves recalling the formula which you're given for the variance of a geometric. But one little exam point here, which doesn't confuse some student, the word instead is used here, which means that ignore all the values from before. P is not 0.3 anymore. The only thing that we have from before is it's geometric. Okay, so P is not 0.3 anymore, so we're basically finding the new value of P, where EX is where var x is equal to 42. So does 5 marks, 5 nice easy marks in my view of this. So we're given in the formula book what the variance of a geometric distribution is. So we've got var x for a geometric is equal to 1 minus p over p squared. And we're told that that equals to 42. So rearranging that, we get 42p squared plus p minus 1 equals to 0. Then we can factorize that and get 6p plus 1 and 7p minus 1 equals to 0. That's going to give us the plus p, isn't it? So that gives us p equals to 1/7. But we do need, because there's a few marks available here, 5 marks, so we do need to explicitly reject the p equals to the other value. P is equal to minus 1/6, since P has got to be greater than or equal to 0. So we're going to reject that. So P is equal to 1/7. Now we're nearly there, because the EX, which is also given in the formula book, is 1/P. So the reciprocal of 1/7 is 7. So nice 5 marks at the end there compared to the 2 and the 2 earlier on in the question. It's a bit unusual. They normally make us work harder for 5 marks. But there you have it. I hope you found this video in some way useful. Thank you. Bye.